Thank you.
So
We start maybe
let me
1
check.
minute.
Okay, I will try to turn on this video, but I don't know how it looks like. Thanks for joining today, and I'd like to say heartily congratulations for all participants of this 15th year of celebration of All Russian Science Festival. Dr. Jayakumar Venkatesan here. I'd like to share a few experience and some of the ideas that can useful for the future human spaceflight research and International Space Station experiments. As you know, the first animal Laika was on the world, in November 3rd of 1957. It was the greatest achievement, and this paved a biggest stepping stone for human spaceflight research. So this is how we call today is like the hero of our dog Laika. So this is the human spaceflight. It is normally it is defined in general. It is like referred like a crewed program, or it called some person or animal is traveling to space. So this is called manned spacecraft, or like a living being spacecraft, something like that. So mostly this will operate like autonomous mode, or maybe some of them are like. So this is the one. The first human in the space was Yuri Gagarin. The first human in the space was Yuri Gagarin, like who flew in Vostok 1 in the spacecraft, and he has been that the humans have been flown several times to moon, and 9 times from 1968 to 90. That the humans have been flown several times to moon, but there will be like many of the programs. I mean, the human spaceflight programs and research have been but there will be like many of the programs. I mean, the human spaceflight programs and research have been taken care by India, Russia, and USA also planning for moon exploration missions like Artemis, and JAXA, China, and Europe. So this will be the biggest first step of Laika made that historic mission, and then after the Yuri Gagarin, so everybody feels the safe we can fly to the space. So this is how the things have been started and working for today's human space flight research. This was the first private human was taken to the space flight. It was happening in 2004, something like the human space tourism projects have been started, something like. In the picture, you can see the doctor of medical sciences, chief research associates in IBM in Russia. So they were the man who behind some of the successful flights of Laika and selecting the dogs and flying to the space. This program is like the Fortune Net. I met them in person. And basically, the human spaceflight research, they will start the underground experiments called analog missions. One of the analog missions is in Moscow in IBMP facilities. They use to Moon and Mars analog missions. This is how they start working on. And mostly the analog missions are, like to prepare the near-term future expeditions like asteroids, Moon, Mars, or maybe some kind of the significant role in the asteroids, Moon, Mars, or maybe some kind of the significant role in the space research actually. So this can be kind of the things, the situations you can call it like many of the experiments we cannot perform on the space because it's like quite expensive, and some of them are you know it requires a lot of money and funds. But what we can do is we can test the experiments. That is when you have not enough money, and we can test your technologies that can useful for your countermeasures. So this will be the great idea to start working on the analog platforms and testing platforms. This will be the good idea. Those we can test before to the flight to International Space Station or something like that. And next is like mostly the ground-based analogs. Some of them are underwater experiments they are doing actually. This is some of the analog missions. Is mostly they use the fields to explore like Mars like a terrain or Moon like a terrain or something extreme environments. Something like they can easily to predict, and they test your robotic technology and to test your mobility, habitat, communications, something power, and some isolations, something like a team dynamics, some of the things we can observe. Mostly, what is the major hazards and something like you can see the space is dangerous. It is like unfriendly place. And one goal of the analog is mission is to like posing something like to safeguard from the harmful stresses, something like we have to extreme gravity fields and the isolations, there are some radiations, and there will be like a distance from the earth and a different environment. So these are all the major challenges. The types of the analog missions is like the first step to be an astronaut or cosmonaut is like some of the example missions have been successfully done by Hera is from US, and the Sirius in Russia. This like NASA and Roscosmos the mission supported mission, and Antarctic stations. Some of them are test beds and radiation analogs, something like. Some analogs have been used by NASA. Also, there will be like suborbital flights, parabolic flights, and some of the desert rats, and something on Mars research, something like exploring the Mars research, something. This is the one in Moscow. You maybe visit the IBMP the facility. This was the next to promote. The next mission is going to start. It's like the Earth like simulation, like Moon simulation, Mars simulations. It's like they are going to carry out for 240 days in this. So there will be like you can see me here. This is me here, and we are also. It's like a volunteer test cosmonautic stuff that you can work on this scientific research facility in the ground-based International Space Station. This is like simply a ground-based International Space Station, something like. So this some of the space exploration scenario is like normally after the Vida model, after that even Russia started building the International Space Station, and after that the space stations, after the construction of international cooperation, the International Space Station has been successfully now operating, and they done enormous of research activities that have been carried out. And some of the things are like, for example, like a CubeSats launch releasing from International Space Station, and the 3D bioprinting in International Space Station, and there will be like a moon exploration, moon communications, the moon landing, and moon explorations, robotic missions from Earth to Moon, and something you can call like this, like the gateway. The new International Space Station is going to be built. So this is the next milestone. And also after exploring the Mars, also this some of the thing. This is the general overview of International Space Station. It consisting of the first
TikTok.
Russian model, first the Russian model, and the USA model, and the European model, and the JAXA and Chinese model was there, but it's not there now. So this there will be like many of them are cargos, like essential supplies. Some of them are like habitat model, means where you live. Some of the service model, you do the electronics and do some testing, some experiments, and observatory stuff. There are many things that you can do on there. This is normally the human factor engineering in general. There's like there will be like in general they do the crew selection, and they do the basic training, and it's like advanced training methods, and also the specific training for special operate the equipments, and the crew readiness. There will be like life support and flight shoots, something, and the human science and bioastronautics. It is like everything will be covered over the course of a period of time, and that's how the Yuri Gagarin Center was operating and helping many people fly to International Space Station, something. So this is the some of the, here you can see there are the three test crew members and volunteers in this, the Mars 500 mission, and the series previous batches of the project it is in Moscow, and Mark is the head of the laboratory, head of the training programs there, and it was taken during my last visit in last November. And they do the science experiments, like there will be like a dry immersion test. There's like it's like volunteer students or young scientists. They also take part in the missions called a dry immersion mission. It's like a volunteer need to spend for 3 to 21 days. It's like a bathtub, something like it simulates the changes of human body. Mostly it is like the idea is in dry immersion, the body is supported by eventually without the pressure point. It's like this is much like of floating the astronaut in space. And what are the things you can able to do here? It is like the affected areas they will use to study about your eyes, and study about your brain and hearings and your heart and your liver and your bone and your muscles. Okay, and mostly these results could help the diverse measures of the astronaut for bedridden for the people on the earth. Actually, this is the dry immersion test. Some of the volunteers, they have taken the dry immersion baths that use it to create the aspects of living the weightlessness like on the earth. So this is like a ground-based International Space Station, like the something. It's always in your life you have a hero. It's like for me, I consider it's like the cosmonaut Sergei Vasilyevich Avidiv. He was he was stunned and he was worked with in a Mir space station, and he have traveled around 11,968 times of the sun of the Earth, orbited there, and also he traveled more than something like 515 million kilometers, and he spent more than 747 plus days in space. Okay. So this was the best thing. So I consider myself as like someone in your life to be a mentor and someone to inspire you in your life to become something. So we do the significant space exploration cooperation activities. That first one in the image you can see the Soyuz spacecraft simulator that is in Zhukovsky in Moscow. We do the training for the children and the people who, and also the space enthusiasts. We have the professional simulators also that you can operate and fly yourself to the International Space Station. And we have signed an MOU and a collaboration agreement with S7 Space for commercial space operations in near future something. So this is the photo with Rogozin was taken during 2018 delegations of International Space Launch something. You can you can see the smallest rover, that is tiny rover. It is on the moon exploration. The center image is like the cosmonauts which are with it. So we do the constantly finding the space education and the activities and mentoring the space programs, something in Russia. So there will be like we have to fully pledge for the human exploration. For example, if you want to fly to the space and you wanted to spend your vacation on the moon, imagine like the people are going to those sea, oceans and all, they're spending in Russia the time. But in the future, what will happen? The guys will start, going to the Mars or going to the space and coming back. This is like you can spend your vacation, something like that. So mostly the private companies and research institutes are being together like cutting edge technologies that today we are giving the creative technologies, like for example, 3D printing, mining on moon. And we made this first with our partner 3D Bioprinting Solutions. They made the first tissue printing in International Space Station. This will be the world's first, so the experiment has been done on the demonstration done on International Space Station. And we would like to go to the moon, and we have to start cultivating the organ printing stuff. And so this will be create the history. Like first Russian experiment will successfully done the tissue printing on moon, something. So next is like agriculture concepts, the factory, something. So this is like a agroponics that you can build your greenhouse environment in the factory. It's like this look like one capsule with the plants, and that's something you can build on. Some of the we are planning to current right now. We are proposing to the Russian space. Like orbital segment. This is like a small workstation workspace. This is can be like a multi-purpose workstation. It's like a very small one, 3-meter cube, and where you can store your the experiments, something. So there will be like a power and something like we are planning to send um, some 600 to some 110 kilograms of cargoes to the space, something like it is. In general technical implementation of Raswet, it has the thermostat and the onboard power outlet, multi-purpose workstations, and it has the vibration isolation machines, and it will be the quite compact in this. So you can look at here the some of the technical implementations. This is called, we name it like a universal scientific equipment platform. This can be USB components will be delivered to ISS by Progress cargo or maybe the Soyuz spacecraft. It has some the adapters that you can able to see the small satellites, kind of 1U, 2U, 3U satellite sizes. So this will be the small adaptable box that you can easily to transfer back to the Soyuz spacecraft, and we can send some memory cards and some functional data that you can able to get it. So some of the technical implementations you can call here some the power supply, remote control panels, softwares, and some of the documents, something like. Some of the interesting, this is the festival now, science festival. So we are planning some of the interesting science experiments. I'd like to invite the universities in Russia and students, school children. They can also participate in the future space station experiments, like doing by exploring the behavior of different types of water solutions. You can see here there are like different water solutions and chemistry is something like we can able to understand the environment, especially the temperatures, and increasing the demotions and the dynamic magnetic fields, and the immersible liquids and the solutions and the magnetic properties, just like a saline solutions. The most idea, the objective is, the collecting the comparative data about the behavior of solutions and technical and biological analogs of environment, just like Earth-like conditions of the spaceflight conditions. So this is most interesting one is like a flying machine in the something you can fly in International Space Station, like your friend, your buddy, or something like. It's like school and student drones are based on the universal scientific equipment platform. This mostly the idea is like technology and the space robotic systems. So maybe we can send the robots names of Alexander Pushkin or something, some interesting names, and also we can dedicate the missions also. This is the survival of experiments. This mostly the objective is to research in the microorganisms, and it has a resistance to the space flight conditions mostly. The idea is like to behavior of materials and organisms under the external environment is like it is constantly changing, and the gas compositions, mostly the pressure and dynamic magnetic fields. It has some kind of the we use the yeast, like how the yeast will behave in International Space Station, something. And this is called the Nano Sensors. It's like technological researchers have been like creating the new type of the sensor devices that can be useful to monitor the inhabit the compartment or the gas compositions, and it's like a small gas sensors and micro sensors and analytical softwares and nanomaterials, something like. Some of them are here. The components is like technological researchers for the exploring the possibilities that using the chip and the electromagnetic components, we can test in any electronic components, the microgravity experiments that for either commercial or maybe the educational research, something that we can do. This was the interesting things of modes of behaviors of high organized social systems. The ants are the highly organized and social experiments. There are the insects, and they can do the studies and uh, do some formicorium, something like. The research on the ant family is like modes of behavior changing, aspects of living changing, ethereal structure of microgravity. This is like ISS radiation monitoring, some of the key experiments that we can able to deploy from International Space Stations, from space weather properties research. And can be used for to tracking the cosmic rays and Earth storm activities, and it also has some kind of digital camera, and also the use cloud chambers, something we can able to track the cosmic rays. This is like protoplant. This is the research is different type of surface, a partial adhesion of big structures in the microgravity. It's like mostly protoplanetary disk is growth space conditions. It's like the simulation of the growth conditions. This is the bioenergy. I think this is the most technological advancements in prototyping and testing of alternative power supplies in microgravity. You are in microgravity, you may experience less energy or some kind of the power supply. So there, how you can generate the electricity, something doing the microbial fuel cells, and that this device is converts the chemical energy to the electric energy by the action of microorganisms. By microorganisms, you'll generate the power and electricity to you. This is one of the interesting research. Uh, this is this is the microorganisms. It's like it can live in minus 271 degrees Celsius, and also it can able to stay in a liquid helium. It's like around plus 100 degrees Celsius, something. In 100 degrees Celsius also it can able to withstand. The size is like very tiny. It's like it's like 0.1 to 1.5 mm in the size. It's like this is like 1,000 times of radiation it can withstand. It can able to withstand that kind of thing. So this was the most interesting creature. I mean, this may be the best thing maybe we can test in the International Space Station to understand the future behavior of human space flight research. This is the hottest topic right now on how to explore the different planets, something like. So by doing this research, we can able to find some innovations in human space flight before we are going to the moon or Mars, something. So this one is the 3D bioprinting solutions. Russian partner, they have successfully demonstrated in International Space Station. It's like it's called the magnetic bioprinter. This is called simply a scientific equipment. The cosmonaut is, you can see here, is holding the 3D bioprinter. So this is the general idea of bioprinting. So printing happen in the space. This is like a cartridge. Here you can see this is the delivery center. This is like a single experiment. This is for multiple experiments. There will be like the bio ink cartridge here. So normally what we'll do is we are launching from International Space Station. The first step is like cultivation of cartridge of thyroid glands here, and second is formation of tissues. And there will be like the formation of tissue spheroids. It's like goes to 4 to 8,000 cells in the sphere with a diameter. There will be like up to 200 microns normally. So it is lower than the coronavirus, like this is very small in the spheroids. This is tissues. And the third is like magnetic printer. It's start doing the action is like printing the construction of in the incubator, and after 24 hours, so the fixation of for the samples, and then we sending the samples return to the Earth. And we have successfully demonstrated in a commercial thing is like 3D printed chicken nuggets in KFC in Moscow, and we guys are making the fish, and also we are making
Переслал уже, да?
Студия, можете, пожалуйста, звук на некоторое время подать, чтобы я вас услышал?
Да, можно говорить.
Да, раз, два, три. Так слышно.
Я вас услышал, да, все отлично. Студия, вы в эфире.
В смысле, не рекомендуют.
Ребят, всем привет! Наука плюс продолжается. Всем привет с физтеха. Как раз у нас московское время 13:00, а значит самое время разобраться в главной новости, за что же все-таки дали Нобелевку по химии, дали ли ее по химии или нужно было по какой-то другой дисциплине давать. Вот, давайте разбираться вместе с Павлом Волчковым, исполнительным директором Центра живых систем и биофармтехнологий и руководителем лаборатории геномной инженерии МФТИ. Павел, добрый день.
Добрый день.
Фух, смог выговорить почти
Да,
с первого раза.
я тоже, на самом деле, не каждый раз получается. С утра, в общем-то, лучше не спрашивать.
Да, поэтому, видите, чуть попозже лекцию поставили. Итак, первый вопрос. Как известно, в этом году Нобелевку по химии, кстати, почему именно по химии, получили ученые за совместную разработку методов редактирования генома. Вот, первый вопрос, собственно, почему по химии, а не по какой-то другой
Почему по
дисциплине?
химии? Ну, на самом деле ответ, если короткий, то я не хотел бы, конечно, обижать химиков, но действительно химия немножко исчерпалась. Сейчас в меня полетели там град камней, копии от тех самых химиков, которые нас слушают, а, пожалуй, они нас не слушают, поэтому, видите, я здесь сижу, и со мной ничего не происходит. Шучу. Дело в том, что основные открытия по химии были сделаны там, в веке 18-19, начале 20-го. А сейчас химия, она уже, знаете, стала такая, ну, скажем так, заглядываться на соседей. Химия заглядывается и на физику, физика на химию, там появилась так называемая наука о материалах, которая уже, знаете, интегрировала все на свете, чтобы мы могли летать на сверхзвуковых самолетах, и они чтобы были очень легкими. Вот так же происходит и с сопряженными направлениями химия плюс биология. И химики на самом деле искренне считают, в общем-то я не буду их разуверять, что биохимия – это тоже часть химии.
Понятно. То есть это уже вопрос, вот эта наука на стыке, дальше уже начинается интерпретация, а стык-то ближе к какой науке?
Конечно.
Ну что ж, окей, допустим, разобрались, что химия, да, или не химия. А за что, собственно, дали? Можете ли вы нам как-то популярно расшарить вообще, что происходит, что за такая технология? Вот.
Далее за технологии действительно она очень популярная стала. И те, кто не знает, давайте я вам как-то совсем банально объясню, что это такое. То есть это технология, которая позволяет нам редактировать геном. В том исходном варианте, в котором она была открыта, это такие молекулярные ножницы, которые позволяют разрезать геном, нуклеиновые кислоты, ту самую ДНК или РНК, соответственно, данная технология была открыта чуть позже, вот, в определенном месте. Причем это место мы можем запрограммировать. Ну, иными словами, мы можем просто сделать, в общем-то, определенную так называемую штуку под названием Single Guide RNA, то есть та самая гидовая РНК, которая, в общем-то, может вместе с тем самым комплексом КАС-9, например, таргетировать, то есть разрезать именно то самое место, которое мы хотим. По какому принципу? Ну вот та самая Single Guide RNA, гидовая РНК, она кодирует небольшой кусок РНК вот в одной из частей своих, который будет комплементарен непосредственному участку, который мы хотим разрезать. Таким образом, ну вообще в чем крутость всего процесса, мы фактически вот эти вот молекулярные ножницы можем сделать, ну, буквально за неделю. То есть это позволяет нам создавать классные геномные инженерные механизмы, вот, инструменты, не как раньше, там, в течение 10 лет, там, или чуть позже, когда сначала у нас были, в общем-то, технологии, когда мы пытались это строить как-то рандомно или там как-то попробовать отредактировать, не имея, в общем-то, направленного инструмента редактирования. И тогда мы уповали на отбор. Соответственно, мы могли вносить как-то рандомно мутации в геном того или иного растения, бактерии, животного и отбирать, то есть производить селекцию. И по понятным причинам, когда вы это делаете, ну вот совсем случайно, как бы уповая на случай, то в вашу группу, выборку должны были входить миллионы, а может быть миллиарды тех самых примитивных событий, модификаций, которые случайно таргетировали как-то, ну вот в зависимости, опять же, от размера генома. Вот, и вы потом их отбираете каким-то образом. И, в общем-то, тем лучше у вас отбор получался, чем лучше вы саму систему отбора придумали. Вот. Но потом человечество изобрело нуклеазы на основе цинковых пальцев. Это драматически на самом деле усовершенствовало систему редактирования. И вот первая компания, которая была сделана, это компания Sangama Therapeutics. Она, кстати, была сделана с участием нашего с вами соотечественника, вот он уже 30 лет живет в Соединенных Штатах, это Федор Урнов. Вчера я имел честь, собственно говоря, с ним опять же в эфире общаться ровно по этому поводу. И Федор Урнов один из тех самых основоположников редактирования генома, собственно говоря, вот это словосочетание редактирование генома он и придумал, на английском опять же. Вот. И потом уже появились более прогрессивные редакторы. Это редактор на основе так называемых талинов. Это тоже нуклеазы. Вот. Чем отличаются первые от вторые? Ну, просто потому что, чтобы сделать первые, вам нужно там несколько лет, чтобы сделать вторые, вам нужно, в общем-то, несколько месяцев. И потом появились те самые CRISPR-Cas эффекторы, их, собственно говоря, открыли Дженнифер Дудна и Эммануэль Шарпентье. На самом деле не только они, но как это вводится, в общем-то, Нобелевскую премию нужно дать кому-то конкретному. Вот. И Нобелевский комитет счел, в общем-то, их наиболее достойными этой премии, и они ее, собственно говоря, получили. Ну вот после 2012 года, 2012,
Да, 2012.
Вот. Прошло всего 8 лет, и, представляете, за столь короткий срок, ну, на самом деле быстрее получал премию, на мой взгляд, только Яманака. Синий Яманака, который, по-моему, первые статьи у него про получение индуцированных плюрипатентных стволовых клеток вышли, там, по-моему, в 2008 и в 2009 году, а премию он получил, если я не ошибаюсь, в 2010. Вот, то есть это фактически вот так, да? То есть...
Вы у меня буквально вопрос забрали.
Ой,
я как раз хотел сказать, что да, как известно, технология, которую мы обсуждаем, была открыта примерно в 2012, а у Нобелевки есть такая практика, что обычно спустя десятилетия кому-то что-то вручают, осознавая важность, а тут вот прям такой короткий срок. Вот, неужели это говорит о какой-то прям колоссальной важности?
Ну, вы знаете, вот в случае с Яманакой и его открытием и созданием индуцированных плюрипатентных стволовых клеток у мирового сообщества просто не было вообще никаких альтернатив. Это прям вот Нобелевская премия, ее нужно присуждать. А в случае с CRISPR-Cas эффекторами было то же самое. Проблема была в том, а кому именно. То есть вот 8 лет потребовалось, чтобы все-таки занять чью-то сторону, потому что вот с одной стороны были Эммануэль Шарпентье и Дженнифер Дудна, а с другой стороны был коллектив из Broad Institute, это один из институтов, аффилированных с MIT, и ряд ученых из Гарварда, которые все время на самом деле судятся с первыми двумя, теперь уже с нобелевскими лауреатами. Вот.
Патентная битва, да?
Патентная битва, да. И суд США на самом деле сейчас на стороне все-таки вторых, то есть на стороне Broad Institute и Гарварда. Они более сильнее, но в Америке, опять же, сильнее обычно не тот, кто правее, а тот, кто лучше судится, то есть у кого лучше юрист. Вот, поэтому тут надо все-таки... Нобелевский лауреат, Нобелевский комитет, извините, решил, наверное, все-таки поддержать, ну, как это, создать противовес небольшой, потому что уже девушки больно сильно начали проигрывать в судах по всем фронтам.